Lesson 52, Chemical Mixture Problems, Type A, which means that there's probably a lesson coming up later called Chemical Mixture Problems
B.
And C.
No, just two. What I like to do, though, is I like to give you one process that, if you think through this way, it'll apply to both types. So here's how I want you to do these. We need two equations. One of them is going to be volume, and the other one has to do with concentration. Not the game, just percentages of certain chemicals. Always start with the volume. Start with volume. And with these kinds of problems here, take a look at this little diagram. You zoom in.
That's not really staying.
The idea here is we've got three buckets, so to speak. We've got a bucket of one liquid and a bucket of another liquid, and we are going to dump some of each into the trash, or another bucket.
There's a Band-Aid in there.
That's totally relevant. Okay, so we've got two containers of liquid with different concentration levels. We'll get to that in a second. And we're going to mix some of each into another bucket to get the same type of liquid but with a different concentration level. Now, the two buckets need names. And we could call them whatever we
Patrick
want.
and Sylvia.
That would work too. Patrick and Sylvia. Sponge and Bob, you know, whatever you want. So, yeah. So we need two names for them. Some, I think, other math textbooks are going to just use X and Y, which is fine. What the Saxon books do is they call them PN and DN. Just one's poured in, the other one's dumped in. Not that there's no significance to it. It's just we have to have some way of telling them apart. Okay, so. In this example here of, let's see, let's start down here. Example 52.1. We've got a druggist has one solution that is 10% iodine, another that's 50% iodine.
Wait, like a druggie?
Druggist.
Oh,
Yes,
like a pharmacist?
Yes, it's a legitimate drug pusher. Dealer, yes. That's what,
Oh, okay.
so how much of each should the druggist use to get 100 milliliters of a mixture that's 20% iodine? So in that problem, they've got four numbers there. We've got 10%, 50%, 100 milliliters, and 20%. What is, always start with volume. What in that problem has to do with volume?
The druggist used to get
100 milliliters. And that's, and the question is, are we starting with 100 milliliters or are we ending with 100 milliliters?
Ending.
We need to end up with 100 milliliters. So we've got some of this and some of this that we are mixing together to get 100 milliliters. Actually, what I should do is make this generic. Ending amount. So in our problem here, we've got our two buckets, Sylvia and Patrick.
Yes.
And however much of Sylvia and however much of Patrick we're dumping into this bucket, but we need to end up with 100 milliliters. So, always start with the volume. Now, the next thing is, we need, how many variables do we have, by the way?
Two.
Two. So how many equations do we need to be able to solve this?
Two.
Good job. So what we need now we need our concentration equation. And what we do for the concentration equation,
Blue.
there's blue. To get the concentration equation,
Write it down for me, Chris.
What?
Write it down for me.
and you insert percentages. Here's where the percentages go. Probably should put the percent sign right there. So what we do is, I'm going to copy down the volume equation. Except now what I'm going to do is I'm going to specify what each of those volumes concentration levels are. Those are percent signs. Not the prettiest thing in the world, but it works. So, in our example here, let's copy our equation down. And we are going to put in the concentration levels. So we've got here, see the druggist has two solutions. One solution is 10% iodine and the other one is 50% iodine. So let's put in 10% and 50% for our percent concentrations, and we need to end up with 100 milliliters, that is 20% iodine. And there is our second equation. So notice, I copied down my first equation, leaving space in front of each one to put the concentration level. Now, in this problem here, we were talking about percent iodine. The book does not throw you any curveballs, at least for a little while. It's kind of easy on it, but one thing you have to pay attention for the concentration equation is you have to be consistent with your units, or with what you're talking about. Be consistent. That's an I. Now in this problem here, it said that this stuff is 10% what?
Patrick.
Math.
Iodine. 10% iodine. So if we're talking about percent of iodine, now, how many of you have taken chemistry?
Yeah.
Either are in or have taken chemistry? About half of you. In chemistry, what does the word solution mean?
It's.
We just
Went
went
over
over
that.
this.
I said it was like it had to do with like a liquid.
Yes, it does have to do with liquid. What? It's a mixture, right? Where you have something mixed in something else. Now, usually it's either one liquid mixed in water, or some kind of a solid mixed in water. Something dissolved in water is typically what you're talking about. So if I'm talking about a solution that has iodine, that means iodine in water. So if this bucket here, is this Patrick or?
That's Patrick, and
Patrick.
the other one's Diana now.
Oh, it's,
Well, because
she changed her name.
Well, Patrick and Sylvia, like Sylvia starts with S, not D.
What was Sylvia thinking?
I don't know.
I don't know
So
either.
I changed it to Diana.
Okay, so now we have Patrick and Diana.
Yep.
Sylvia went through an identity crisis and changed her name to Diana. Okay. So Patrick here, if Patrick is an iodine solution, how many ingredients are there in Patrick?
2. Water
There's the
and
iodine dissolved in water.
Yeah.
So if Patrick is 10% iodine, what percent water is he?
Hey, 90.
90. There's only two things, and you talk about how much of it is one thing, then the rest of it is the other thing. If this is 10% iodine, I'd better not, if Patrick is 10% iodine, I'd better not talk about Diane being a certain percentage of water.
Oh, because you have to be constant.
Got to be consistent. If we're talking about percentage of iodine with here, then we better talk about percent iodine here and here.
Okay.
One of the points that the book makes, I'm not going to make this point on the board so much, but is you can work it either way. You can do it as percent iodine as long as you're consistent all the way across, or you can do it as percent water as long as you're consistent all the way across. So, now that we have two equations, two unknowns, it's your typical scenario there, substitution or elimination. Theoretically, you should know how to do this.
Purple, not purple.
Orange.
Purple, not purple, orange, green. All right, we'll go with green. I'll just do this real quick because this solving two equations with two unknowns is something that you already should know how to do. Substitution or elimination?
Substitution.
Substitution. First equation solve for what? Pn?
Yeah.
Okay. 100 minus
Wait,
dn.
does P and D just stand for the two?
Yeah.
Patrick and Diana.
Yep. And I'm going to make a point about that at the end here. Now, by the way, one thing that I like to do, hopefully this won't confuse you, but I like to make numbers smaller before I make them bigger. If I take all of this and I divide everything by 10, now what do I have? 1pn, which is just pn, plus 5dn equals 2 times 100. And now my numbers are a little bit easier to work with.
That is true.
It's just kind of a general tip whenever you're working with these things. So we are going to substitute this in for Pn right here. So we've got 100 minus dn plus 5dn is going to be plus 4dn equals 200. Subtract 100 from both sides, and 4dn equals 100, and then dn equals 25. Am I done? No. No. Because the question says, well, I set up my equations, I plug stuff in, solve for variable, and now's a great time to stop and see what the question's asking for. The question was asking how much of each of these solutions.
So you can do anything.
I have dn now. What's the fastest way to solve for pn?
Plug it in.
Plug it in. I can use any of these equations here. I would go for this one here, or this one, but if dn and pn need to add up to 100, that means, well, louder?
75.
Okay, that works too. So what if, so my answers are 25 and 75. Have I been clear in my answer now?
Yeah.
No.
No.
Which one's which?
Well,
Iodine.
Patrick is 75 and Diane is 25.
But here's the thing. What if I called Patrick Diana and Diana Patrick while I was working the problem?
Well,
Wait,
they're
are
boys
Patrick
and
and-
girls.
Are Patrick and Diana in the original math problem?
I thought we were talking about drugs.
We are. Patrick and Diana are both druggies.
I need to quit.
Whoa. Wait, I thought they were
I'll
substances.
slap Patrick
Okay.
up.
Right. Well, here's the thing. So we know we need 25. Now, for one thing, what types of units did we have here?
Iodine.
That was the percentage concentration.
Oh, milliliters, sorry.
That's going to come into it also. So we have 25 milliliters and 75 milliliters, but how do we know which was which? We made up Pn and Dn. We made up Patrick and Diana. Patrick and Diana are our imaginary friends. They don't exist in the math problem. How do we tell the difference?
The one that was 10% was?
Yes. So we have, in order to be clear in our answer, because how do I know that you put the 10 here and the 50 here? What if you did it the other way around? How am I going to know that grading your math work? So when you have your answer, I don't care about Pn, Dn, X, Y, Patrick, Diana, or whatever you want to use for variables. Does not matter to me, but I do have to know that you're talking about 25 milliliters, let's see, of the Dn, 25 milliliters of the 50% solution, and 75 milliliters of the 10% solution. I have to know which one is which as far as the concentrations that we were given to work with. And so now I have an answer that is meaningful. Because the question is, how much of each solution, there's a 10% solution and a 50% solution, how much of each should the druggist use to get 100 milliliters or 20%? Well, he needs to use 25 milliliters of the container that has the 50% solution, and he needs to use 75 milliliters of the container that has the 10% solution. And now we have clearly given an answer to the question. We have solved this druggist's problems.
I bet Walter White went through this.
That's the Breaking Bad guy, isn't it?
Yeah.
I haven't seen the show. There's only so much time. So, one more example real quick. Except let's do it, quick.
Right.
Who says
I heard
that?
Brack. I heard Brack. We'll go with black. Okay. What? Alright, 52. So 52.2. Let's see. Chemist has one solution, not 10% salt. Now let's read this one carefully. A chemist has one solution that is 10% salt and 90% water, and another solution that is only 2% salt. How many milliliters of each should the chemist use to make 1,400 milliliters of a solution that is 6% salt? What are we? We have two equations, volume and concentration. What do we start with?
DN plus DN.
We start with volume. We've got two things that we're adding together to make sum total. Always start with volume. What is our volume in this problem?
DN plus DN equals 1,400.
And our volume is we need to end up with 1,400 milliliters. Stop playing with the calculator. You wouldn't have to pick this time to play with the calculator that actually makes sound. All right, so if we have the ending volume, we don't know how much of this, we don't know how much of this. Patrick and Diana, whatever, poured in, dumped in. And how do I get my concentration equation? I copy that down, leaving some space for the concentrations in front.
Beautiful.
We've got, now it says that we want to end up with a solution that is 6% salt. And we have a solution that's 2% salt. And the other one says it's 10% salt and 90% water. There's extra information there. If we were given salt, we need to do the other one salt.
Oh.
Because we have to be consistent.
That's a really nice 10.
Tan?
10.
It's not some regular.
So now we have 2 equations, 2 unknowns, and we can go from there. Just for kick, we did substitution over here. Let's do elimination on this one.
Purple. No, you know what? Brown came back up.
What if I took this equation, multiplied it by -2?
Wait, why are... Oh, because are we using a 10 and a 2 because we have to stay with salt? We can't do salt and water.
We could do, well, that's just the point. Pick one.
We can
Either
do
do it
90
with salt
or
or...
10% for water. Like 90% PN plus...
If you wanted to do it in water, you would have 90% water for this stuff. But this one, the other stuff, is 2% salt, therefore 98% water. And we need to end up with something that's 6% salt or 94% water. Doesn't really matter which way you do it. So this one would be, this is water.
Okay.
This one is salt.
But we have to stay constant.
You have to be consistent. Whatever percent concentration you're talking about, you got to stay consistent all the way across your equation.
Right.
Now you could reduce.
Okay, so see, I was going to take this equation, multiply by -2, so I've got -2 Pn minus 2 Dn. -2 times that is -2800. By the way, what's 6 times 1400?
Wait, why don't you get -2?
Let me use the factor.
So I'm going to eliminate. I took this equation and multiplied it by -2.
8400.
What is it?
8400.
8400. Alright, so those cancel. We've got 8 Pn equals 8400 minus 2800 is?
Well, I'm trying to do it on a calculator, but it won't work.
That's
No,
because
700.
you're a TI person using an HP.
700.
Hands cancel. Yeah, check this out. 8 goes into 56 how many times?
7.
7, leaving 7 and 2 zeros. So Pn
700
equals 700. And then Dn is going to be what?
700.
Go back to the simplest equation, right here. If Pn is 700, what's Dn? 700. Am I done?
Yeah.
No way, Holmes.
No. I need my units. What units were we talking about?
We're going to use salt.
Volume
Oh,
was
milliliters.
milliliters. And we have to tell the difference which one's which.
Doesn't matter.
Now in this particular one it doesn't matter because it was the same amount, but usually it'll be different.
Gotcha.
So you kind of lucked out on this one. Well, see, one of them was 10% and the other one was 2%. And so for your answer, how about pink? So for your answer, I don't care about your variables. I need to know how much of which concentration. So there it would be your answer for that one.
Your exit song should be Taylor Swift.
I don't think so.
Why?
Because it's Taylor Swift. The answer's in the question. Should be Taylor Swift? No.
I'm going to make a t-shirt for Taylor Swift, and it's going to be called Swifty Tees.
That's nice, but you're not wearing it in math class. All right. Thank you. We're done.
Wait, you gotta do your sign off. Smosh.
Oh,
Smash.
All right. There